We now move on to our first panel of today, where we're going to be talking about microgrids. We teased that at the end of the previous session, but we are joined on this panel by Kayla Ente, Darren Jones, and Mohammed. I will let everyone introduce themselves for 1 to 2 minutes, and then we will get on to the main crux of the discussion. If any of the panelists want to talk about any other questions, just raise your hand, just so we don't all talk over each other. Perfect. Shall we start with you, Kayla?
Great, sure. Thank you. Thank you, Jordan. My name is Kayla Ente. I'm the founder and CEO of Brighton and Hove Energy Services Co-operative, and we develop renewable energy and energy efficiency projects in a community-funded business model. We're a social enterprise combating fuel poverty in the local community. We have set up a process for it by starting with an energy survey and taking it all the way through to the build and ownership and operation of the projects. And we've done almost 60 projects.
Impressive. That's quite a few projects. Darren, would you like to introduce yourself?
Thanks. Morning, Jordan. Hi, everyone. Great to be here today. Looks like you had a great conference, a great couple of sessions so far. It's really interesting stuff covered. I did listen into the earlier sessions, really interested to hear Jonathan Berry, I know quite well. They do some fascinating things over there. So anyway, I'm Darren Jones. I'm a technology manager at Hitachi Energy. Most people probably have heard of Hitachi at some point. We do an awful lot of diverse and different things, from building nuclear power stations, machinery, consumer electronics. But I work in the energy part of Hitachi Energy. The company's only existed for around 2 years. We used to be part of ABB, so we came from the ABB power grids part. So now Hitachi Energy, we offer a broad range of different technology solutions. Our basic business model is kind of planning, designing, connecting things to electricity grids. So we have a really strong, in our language, they're not microgrids, we call it grid edge solutions. And I think probably that might be some of the discussion today, to try and dig into some of the terminology, because I think microgrids, to me, it's a little bit like maybe 10 or 15 years ago, we were talking about smart grids. And I don't think we ever actually came up with a nice description. I'd be interested to hear Kayla's view on some of the terminology. We might think of it more like smart local energy systems, or, those types of approaches. So, but anyway, we'd have a grid edge solution team, an advisory service. And also, really, to be clear, we don't operate our own microgrids or local energy systems. We really design and build them. And our main strength so far, I'll say, has really been in kind of remote and island communities. The communities that don't have access to reliable power, don't have particularly good resilience, heavily rely on diesel generators. So that's where we see the drivers from our customers, is really to move away from having to use diesel, really to move over to kind of green energy solutions, and be able to optimize people's energy supplies, to bring reliable energy to people who don't have it. We kind of take it for granted when we live in cities and urban locations, particularly in the UK, but we really see grid edge solutions, microgrids, as being a way that, we can get investment where it's needed, which is to really help people. So that's probably enough for me there, Jordan, if that's okay.
To your point of terminology, I've heard so many different terms that microgrid's sort of like a term that I know best.
I know. Well, yeah.
Everyone has a different term, but we will discuss that more. Cass, would you like to introduce yourself?
Yeah, sure. Thank you, Jordan. So I'm Mohammed. I'm the Vice President for Digital Energy for Schneider Electric in the UK and Ireland. Schneider Electric, for those that aren't aware, we've got quite a long-standing history, primarily in energy management. So what you would see traditionally from Schneider Electric is a lot around switchgear and the electrical equipment, everything from the big stuff down to the kind of consumer level that you would see in a housing dwelling and what have you. And then all the kind of technology pieces that go around it. And really what the business has done probably in the last sort of 30, 40 years is move more into that automation space as well as that traditional technology. So we're a manufacturer of that operational technology that we need for the electricity and the energy to flow around. But we've moved now more as well into the automation and the software space. In the last sort of 2.5 years, we've moved even further along into the digital twinning piece. And this is really where we talk about microgrid, or the grid type solutions, is actually about linking into the great, wonderful technology that is getting better day by day, and actually taking the data from it to be able to drive efficiency, to make some actual assessments of how a building's operated or site's operating, and get the benefits, realize them benefits that can be achieved. And microgrid's kind of one piece of what we talk about. What Schneider Electric are able to offer as a kind of end-to-end solution here. So not just the operational technology, not just the software, the design consultancy, packaging it all up, and then ultimately helping a customer maintain that as well through its life cycle.
Well, I was going to start with what are the benefits of microgrids, but I think we should go a bit before there, and we should talk about what a microgrid actually is, and what are the different terminologies. Like, it's a very good point that you brought up. So who wants to go first with describing what a microgrid actually is for those who may not be aware?
I could have maybe have just a quick go, because I'm really interested to hear from Kayla actually about the work she's done down in Brighton, because I've read quite a bit about that. But you just an example of the last kind of big project that we did was over in the US. That was the Arlington microgrid, I think, and that was where the local state had mandated, a high use of renewable energy. Again, I mean, make the point again, to displace diesel generators, where everyone's aware of the kind of, the harm to human health, and this is really. I mean, again, for me, I'm the technology manager at Hitachi Energy. But, the thing I realize is that actually technology is the least important thing. It's the value it creates and delivers for humans. That's what's really important. So to answer your question, Jordan, specifically at Arlington, it was a fairly standard case. They had electric vehicle charging. They had solar energy. We had battery energy storage. And they had a number of critical loads of schools, hospitals. So the system that we built over there, I mean, again, it's not an advert. I mean, Cass is here, they do great things. Schneider do great things, with buildings, fantastic company. So this is not an advert for Hitachi Energy. Other vendors are available, let me say, but the system we put in there was basically, balancing and optimizing those technologies. This is the kind of microgrid concept of, using the solar during the day. Charging the battery, when maybe the demand isn't so great. I mean, we used to think of typical load and demand curves of peaking in 8 in the morning and 5 in the evening. I mean, I don't really think that applies particularly anymore. However, demand is generally depressed during the day. So that's the opportunity to use the solar to charge the batteries. And then in the evening, to try and really reduce the peaks by using the batteries to meet some of the loads. I mean, it's this kind of idea of optimization, optimization of the assets that you have and making best use of the assets. And really having a much more active control over the assets that comprise, the local grid. I mean, again, saying local is another. What does local mean? Is it a building? Is it a hospital? Is it a campus? Or is it a small town or village? But towards it, really trying to optimize those energy flows and optimize the use of those assets. We'd spent many years, but again, we're kind of more close to the regulated utilities. And I know you want to touch on the kind of energy transition. This whole idea we had for years and years, we build assets, install them, forget about them. After a certain set period of time, they then get replaced. The future needs to be much more about kind of optimizing the use of those assets, and using the available energy generation. These concepts around, trying to use the nearest greenest electron, that you can purchase, is a way of kind of optimizing the use of the assets that we have and making sure those assets are really delivering value for the owners. So that was the last project we did. But again, Arlington was a fairly isolated community, and they didn't have a particularly resilient electricity supply. So the thing they want to do is just kind of secure that energy, for their future, to allow this community to grow. And also just a final point from me, and a key point, absolutely key point to me, I think, is there was some of the commercial arrangements that were designed around that solution actually paid back revenues to the local community. This is a way of, people need to see the benefits in their local community. Okay, there's resilient electricity suppliers, but they actually need to see the financial benefits, and it really, these ideas of kind of cooperatives, owning systems and owning assets, the cooperatives investing hard work and energy, and in some case financing those assets. It's these local communities that really need to see the tangible benefits. And I think that's how we get buy-in from the local communities, to drive some of the changes in behaviour, human behaviour that we want to see, that some of these microgrids or local energy systems can deliver.
And that's really key. Like, everyone wants power, but they don't want to have power at any cost. And anything that can lower the cost of that would obviously be beneficial. Kayla, I know that with the work you do, would you like to explain more about like what microgrids are, and like more about the work that you are doing down in Brighton and Hove?
Yeah. Okay. So we set up this social enterprise because energy, the delivery of electricity and heat has traditionally been a commodity, and there hasn't been very much human intervention. And now things have changed significantly, where we have an energy crisis and we also have a climate crisis. So there needs to be a fundamental shift in the industry. And everyone in the industry has been talking about this for years, the move from a centralized energy generation and delivery system to a more local, decentralized system. And so what we do at BESCO is and there are other community energy groups. There are 280 community energy groups across the country, and many of them are working on similar models in their local areas. And it's about generating energy locally, so generating electricity, because electricity is going to be the key driver of the energy industry going forward. It will, as we electrify transport and heat. And so we establish community-owned energy generation, and we use the low voltage network, so the local networks working with the distribution service operators to deliver that electricity to households, using a lot of what Darren was just talking about, maximizing the value of that electricity, driving down the price, because basically the sun is generating that electricity for free, or the wind is generating that electricity for free. And as long as you're covering your capital costs and the costs to operate that system, you can set up a local controller, a smart controller. Probably this is the stuff that Schneider Electrics are doing now. And you can operate that system using the consumption data that you're receiving and the generation data, matching that, and then providing. So BESCO is not an energy supplier. We are not a licensed energy supplier. In a way, that's really good because it makes us very independent. We don't have to work with anyone. We work with companies that share our values, share our community values, because we're in a position now where when the next price cap comes into play in October, they're predicting about 30% fuel poverty across the country. This is a very serious situation in the fifth wealthiest nation in the world. And so we need to come up with solutions, social enterprise solutions to help people stay warm in winter. And we also need to remember that in the past, around 35,000 people died because of cold-related illnesses, and they can't keep sufficiently warm. And also we have a climate crisis where we have 2.5 million people who are still burning oil and some people who are still burning coal to stay warm in the winter. So there's a lot of change that needs to happen, and it needs to happen at a community level, because we're talking about changing the way we think about the delivery of energy. And that needs to start with conversations in our community with people who are trusted, people who are not looking to make a profit from this new infrastructure, but are looking to create a sustainable infrastructure for the people of our communities, and also working on improving the energy efficiency of our homes, because that's a big problem. We have 19 million homes that are leaking energy. And so we've got a big task in front of us, and we need to mobilize people locally in order to be able to do that. So microgrids are important because they're like biomes. I see them as ecosystems where you can manage the flow of electricity between various points. It can be one large building. It can be a lot of houses on a street. It can be anywhere where you have multiple MPANs, let's just say, use the word MPANs, to share that electricity between the consumers and the generators.
We've touched a bit on the point of how microgrids are usually connected to renewables, but what role do they have to play in the energy transition and the move to net zero?
I think that for us, they're a key output from that whole energy transition. So Kayla's kind of talked there about the importance of electricity going forward, the removal of things like gas heating. Ultimately here we can talk about heat pumps, and they're electrically fed. The biggest energy migration in transportation history, which is going to be about moving from petrol and diesel ultimately to electric vehicles. And that's going to affect a huge kind of surplus of demand onto the grid. In terms of how we cope with that, the grid and the suppliers of the grid are ultimately going to put in additional infrastructure. They're going to put in additional points. That's going to come at a cost. And that cost ultimately flows down. And I think in a time where we've got a huge question mark on the reliability of cost and security of our energy, this is almost adding fuel to the fire of actually we need to be more in charge of our own energy destination. And microgrid is kind of an output of that, because what you're doing is basically saying, right, well, I'm going to transition my gas to heat pumps on my sites. I'm going to now put in electric vehicle charging points on my sites. I've got increased demand anyway from electrical consumption. So we can kind of take that all as one and go, right, let's design a system, let's design an architecture which is able to cope with everything all at once, which would be probably excessive and highly costly. And what microgrid does is it helps to come in there and say, actually, there's a more efficient way to build in all that infrastructure and manage it in a way that you can get the renewable energy source, store it at kind of low peak times, and ultimately then reuse it at times when you need to do that. And you're less reliant then on outside sources. Although we kind of encourage this whole bi-directional piece, so you're still having some energy flowing off the grid, ultimately you want to become less and less reliant on that over time. And microgrid gives you the kind of visibility, it gives you the insight in terms of how that's operating and the ability to set that up and then tweak it over a period of time. So it's really important, I think, as part of this energy transition at every kind of level, at a housing level in terms of communities, at a kind of town and district level. Some of the examples we talk about is if you've got large users and maybe industrial type users or large commercial building users in towns and cities, the impact that they can make with a microgrid is not just in their own building, but ultimately all of the buildings and the infrastructure around them. If they can generate net positive, they can actually have an impact on the buildings around them. And then that is then going into a much more of a community-wide approach as well for us. So I think it has a huge influence, Jordan.
I would just like to add something to that as well. I mean, great points, Kaz, thanks for that, and Kayla as well. I think, Kayla, you made a point about One of the things that I think microgrids or local energy systems are strong on is the kind of multi-vector approach, where you can combine transportation needs, heating and energy. And I think in some ways, microgrids are a microcosm of what's needed from the energy transition. This is really complicated stuff, encompassing so many different factors and, so many different actors in the eventual solutions. But in essence, the energy transition, what we need to do as a country is move away from, the last 100 years where we've basically manipulated a few large centralized fossil fueled energy generators using the balancing and ancillary markets, to meet unconstrained demand. Customers can absolutely do what they want. We actually need, as a national energy system, as a country, to flip that on its head now. So we need to begin now to manage demand to meet the available renewable energy generation at any given time on the system. People talk about the intermittency of renewable energy generation, that being a problem. I'm not quite sure that is such a problem, because all the energy generation is intermittent. Fossil fuel generators break down. Most people, I'm sure, on the call might know at least half of the French nuclear fleet is currently offline due to cracks and other various technical problems. So, I think it's a bit of a red herring to say that renewable energy generation is, the intermittency is a problem. But back to the point about now, what we need to do is manipulate demand through flexibility to meet the renewable energy generation. That's exactly what microgrids are doing on a very small local level. It can be small, again, it can be a building, it can be a town or village. But what microgrids are actually doing is looking at multiple different energy vectors, manipulating them and optimizing them, and incentivizing, the people that use that energy to use it at a certain time and in a certain way. I'm old enough to remember when I was younger, being told to turn off the lights, don't leave lights on in that room, unplug things, because the people even older than me, and I'm quite advanced, came from a time when energy wasn't so abundant and ubiquitous and so cheap, but we've had 20, 30 years now, basically cheap energy in the UK, cheap subsidised fossil fuels in the UK, which has driven behaviours of people that use energy, myself included. We almost need to relearn those behaviours now and recognise the fact that, energy is actually a really valuable premium commodity. The way we use energy, the way we perceive energy, the way we approach kind of our lives and the way we approach having to do the things that we do is all underpinned by the energy that we need. And the increase in costs, the points that Kayla made about the cost of energy now, it's absolutely phenomenal, the impact it's having on just ordinary kind of, working people in a way that we never saw in the past. So to me, the microgrid really is an example of what we need to be scaled up to a national system. But that can be, clusters of microgrids. They can offer this kind of interactive optimization of the ways energy is used. Also to respond and pick up on Cass's point about how microgrids connect to the national grid effectively. The mainstream energy system, as I've heard it called. In the end, actually, microgrids can offer services back to the national grid. Again, I'm sure people will know about things like the Pathfinder program now that's being run by National Grid, the flexibility tenders that are being run by all the DSOs around the country. People can actually be empowered to understand that they can offer value back to these, what we saw as large centralized energy companies. Microgrids, I think, are a way of realizing and enabling people to release that value. And allow people to realize that actually that our actions, the way we use energy, has an inherent value. Not the energy we use, the way we use energy and the times we use energy has an inherent value back to the national system. And I think that's where some of the kind of legislation and some of the energy pricing models need to maybe be slightly adapted to allow people to to actually realize that value, and actually get that value back, to help them again with the ultimate, most important objective of lowering people's energy bills.
Kayla, is there anything you want to add there?
Me, Jordan?
Yeah.
Sorry, did you say? Yeah. I absolutely agree with what Darren said. What's happened in the energy network, the centralized network, is we've tolerated a lot of waste. So if you consider the conversion, distribution, and transmission losses that have occurred on the network, traditionally they've been as high as 60%. That's because we don't use the waste heat from the power plants, and just the waste that's associated with the system. And when you think about the housing and how we've wasted energy from our homes because they're not retaining that heat, all of that has to change. And it can only change by working on a local level. So exactly what Darren and Cass are saying is managing the flows of electricity locally and building and strengthening, reinforcing our local infrastructure. In many of the rural villages that we're working with, there haven't been investments in their local network in 60 years. So a lot of these, we're going to need a lot of investment into the local infrastructure. And like Cass says, there is a danger that cost will be passed on to the consumer. And so it's incumbent on organizations to work to ensure that we're creating that value in the microgrid realm, in the smart energy, local energy systems, in order to lower that cost as much as possible.
And a lot of things. You talk about rural communities, and rural communities have started doing more community collaboration when it comes to infrastructure in recent years, whether it's through the installation of fiber broadband or through community power projects. Why do you think that is?
I think the way that government is moving, certainly the national planning policy framework and a lot of things that move legislation only happens when people come together and have a stronger voice to government. And I think people are realizing that that's the only way they're going to get what they need, is by working together and communicating with one voice to government. And we're seeing that over and over again. I certainly worked with one community on the broadband issue, and it's complicated because it's expensive. And so the only way to really handle that cost is by working together to raise the money and make the investment. And that the interesting thing about that model is that we're democratizing investment in our own networks and earning a return. So if the value that is created within these local networks by managing them wisely can be returned to the people in the community. And we're doing a project, for example, now it's a demonstration project where we're going to do exactly that, manage the local generation. So put solar on the roofs of houses on a street where we can and where it makes sense, and then provide rebates back to the people who can't have solar from the profits that we're generating by managing that smart local energy system. And so this should be really interesting to see how people collaborate and work together to drive that value creation and then distribute it across other residents in that community.
I think it's just another great example of kind of activism. And, I think the UK has a strong history of activism and local communities and people coming together, and not realising the government can solve all of our problems. And in many ways, it's kind of up to us as individuals to take ownership of some of these challenges. And I think maybe now energy has come to the top. I mean, the broadband was a few years ago, that was a really hot topic, wasn't it? It was broadband to local communities and lots of local activism. Then to just, you read great stories in the press of kind of people waiting for years for a company to lay a fibre and then say, let's just go and hire a JCB ourselves and we'll just dig a trench across. Let's just do it. Absolutely heartwarming stories, But with broadband, as with energy, electricity, these are the drivers of economic growth and health, and more importantly, human well-being. Even access to broadband and, good communications now. It's not a luxury in 2021 or 2022, forgive me. It's almost impossible to kind of access, the modern world, if I can call it that, without having a reliable broadband connection now. So many services are online. You're so off, being able to engage with what the broader society unless you have those reliable communications. Same as energy now. It is a driver of human well-being. And it's such an obvious one to me. You read these kind of crazy statistics about, I don't know where these numbers come from, but I read one thread that is it true to say that, the sun lands more energy on the earth in one day than humans have used in all their history? So just to be able to, kind of access some of this free energy that, with wind as well. The UK is such a windy place. So there's those renewable energy, reliable sources of energy around us. So, having that community activism, people coming together for the good of the community, it's an absolutely fantastic thing. It really is. But great points that Kayla made about, investment in some of these kind of outlying networks. A big part of Hitachi Energy business is what we call, substation digitalization. Similar to the way I know Schneider are really strong on kind of building management systems, kind of optimizing. Schneider have a great range of solutions for optimizing buildings and building energy systems. And Hitachi Energy, we're heavily involved in substation automation and substation digitalization, because one of the things we need for microgrids is more surveillance by the local network operator. They need to know what's happening at the end of their networks. Today, I know they're doing some, really fantastic things and are spending an awful lot of money. And Jonathan touched on some of that this morning, referencing the Rio business plans that all the DNOs have. But it's always it's a bun fight for investment, isn't it? It's always kind of where are the priorities. So as fast as the DNOs and the DSOs are investing in automation on their networks, this is one of the keys to enabling microgrids to really be able to offer those services back to the national grid. We need more investment on the local electricity networks, more investment in clever automation and digitalization. Again, to touch on some of the points Jonathan raised this morning, almost no conference in 2022 is complete without mentioning artificial intelligence and machine learning. But it is true to say that part of our future prediction is, in the end, today the way those kind of centralized networks are controlled through the kind of standard control rooms at the moment, which is lots of people sitting around looking at screens, waiting for things to happen. Like our vision of the future is that, those control rooms will be completely run by software in the end, because there'll be so much activity happening on networks, microgrids, balancing, inertia, frequency response services. There'll be so much activity happening on electricity networks in the future. The humans won't be able to keep pace and keep track of those decisions. So this is where we see, once you have the automation, you have the clever systems, you don't have the software that can drive this intelligence and optimization. So that's kind of, the centralized investment that needs to happen, to really allow kind of local microgrids and local energy systems to flourish, I think. And also to allow the kind of virtual power plants, to allow different microgrids to collaborate with each other, create these virtual power plants. Again, it's kind of literally taking power back from the kind of centralized energy systems and giving power to local communities, which is, let's face it, I think that's where it should be. I don't think anyone would disagree with that.
I was actually sorry, Cass.
Sorry, I was just going to say just one point to kind of add, and the whole what could be a key kind of driver. Why is there this interest? I think if we just take it back, if we fundamentally see that the outcome from driving decarbonisation and climate change ultimately is, an output of that is having microgrids and having these microsystems, these power systems, essentially, as we've been talking about. You've got a generation today that is coming through and really asking some difficult questions to the generations before them of what have we done And what are we going to do going forward? And is that enough change? And I think the community practice that Kayla is part of and driving here is about taking it in your own hands and doing something. And I think it puts it back into the individual's hands then to say, do you know what? I can actually do something in the place that I'm living. I can actually drive a change and I can do something as a community piece there to actually have a positive impact on the planet. And I think there's a whole generation. I know when I speak to a lot of our graduates and apprentices, not to say that I'm passionate about it, but it's another level. It's another level of enthusiasm and passion. And that's why they've come to work for organizations like ourselves, is because they want to work on projects like that, which can drive a positive impact. And I think that's really important to understand as well.
I want to just touch on Darren's point. We spoke a little bit about how AI and automation are really changing the power grid. But one thing I want to ask is, what additional technologies are really supercharging the microgrid, like energy storage, for instance?
Yeah, well, energy storage, absolutely. I was interested in the previous presentation about supercapacitors, because they've been around as a concept for an awful long time, and I mean a long time. But it's good to see them coming to market now. But I think the kind of standard technology, battery energy storage, vehicle charging, solar, I mean, it's a fairly kind of standard group of technologies and I think tools that we have at our disposal. I think rather than, there's the improvement of the technology that we see as we go along. That kind of happens in the background. I mean, I think the cost of solar is over the last time, Kayla might know better than I, but I think that the cost of solar has come down by like 90% in the last 10 years or something. I mean, absolutely incredible. So I mean, what we can see, I think what we see now is and particularly, with the cost of energy on the other side, it's the economic dynamics, it's the commercial dynamics that we see now are changing rapidly in terms of the performance of the technology and also the cost of the technology. I mean, on the downside, we do see, and again, this is a well-known story. There's nothing sensitive to say that we as an organisation are struggling with raw materials now. Particularly semiconductors, also logistics. The cost of shipping batteries are absolutely phenomenal. The cost of shipping containers, absolutely phenomenal. So there's some downside, quite negative pressures there on the delivery of some of these systems. But I think that's a long-winded answer to your question, Jordan. I think for me, the technology innovation will happen because that's driven by markets. What I'd like to see more, and I think one of the key enabling innovations for microgrids and local energy systems is commercial innovation. We need more kind of intelligent and innovative commercial arrangements between users, energy suppliers, the owners of the mainstream energy system. We need to understand, how those benefits can go back to the consumers of energy and how that can drive change. I think it's on my answer to your question, Jordan, it's the commercial side where we really need, I think, more innovation, and better ways of kind of managing risk and looking at long-term risk, looking at the downsides of what can happen if we don't do some of these things that we've talked about. So I think that's what I'd like to see, more thought. I mean, I was involved for many years with some of the, the Ofgem, the regulator, the innovation incentives. We're not short of kind of clever innovation. Everyone loves technology. In my role, technology manager, everyone loves tech. Well, maybe speaking personally, most people love technology. But that innovation happens on its own because people are just so interested and driven in technology and science. So again, it's a long-winded way of saying, to me, it's the commercial arrangements that we really need to take an in-depth look at, kind of back to basics, I think.
And what about you, Kayla? What do you think is next?
Well, I think for storage, there's two types. There's the smaller storage that you could use battery storage to communicate between generators and share time of day generation between users And if that was in a framework where it was ubiquitous, so any kind of battery storage would be able to exchange data and consumption, that would be amazing. But I think that's one of the limitations of commercial development, is that each manufacturer will develop their own software for communicating between units. And you could legislate that out and make it one ubiquitous kind of communication, but that is not likely to happen. In fact, we have some problems with some of our controllers where we're trying to get data from, say, for example, a heat pump, and the manufacturer won't allow us to access that data. So that could be an inhibitor in the process. But I'm very excited about hydrogen storage. Hydrogen has been around for almost 40 years, and and it's always been a factor. But I think the real use for hydrogen is in large-scale energy storage. And if we're talking about, say, 5 or 10 megawatts in a community to drive all the electricity requirements in that community, and then we combine that with hydrogen storage, we're talking about independent communities that can really take control of their own heat and power and their own pricing and own it. And we're really talking about the democratization of energy systems.
Cass, is there anything you want to add there?
I think, look, I agree fundamentally with a lot of the points there. In particular, the technology will always continue to develop. The cost of some of the renewables, the cost of the storage is always coming down. Anything which is new always has a high price tag, and then ultimately, as you see people using it, it comes down. I think for me, I'm kind of picking on a few examples of projects that we're involved in at the moment, and fundamentally, so our experts are going in there. They're having the discussion around the design and what's needed and how different things can be done. I think that the change is going to be much higher awareness on this. And I think it's not just that it's seen as a silo piece of equipment. It almost needs to be part of standard type approach and standard type design that, when customers, when clients are ultimately looking at this, when they're employing consultancy firms, they have a level of understanding as well around this. And I think for me, then that is the next sort of 3-5 years is the educational piece, the awareness piece around this, and having an understanding of how it will work. Kayla's kind of mentioned things like that, hydrogen storage. We've got thermal storage now as well coming on. You've got the whole battery discussion as well. These things will continue to develop, but the architecture and understanding how that all works, how the prosumer type approach works, having this bi-directional model, what could be the compliance in it, I think that's where we'll see a bigger shift in the next few years.
The thing we touched on earlier, I know, Cass, you mentioned about having bidirectional, where you can connect to the national grid as well as have these microgrids. But obviously not every community has the benefit of being connected to the national grid. So what are the disadvantages or the advantages of actually having a fully self-sustained microgrid?
I'd say historically it was probably the cost. The cost of things like PV, the cost of storage, the cost of the microgrid solution, and having somebody come in was in a different space previously. I think we're moving into a different landscape now, and there's a client that we're working with, and they're looking at a new connection cost to their site. Ultimately, to meet the requirements is what we talked about, things like EV going in on their site, and they want that for every single car parking space they've got on site because they believe that that's where it's going to go. So they need the grid connection, and ultimately the cost of doing that, putting in all the infrastructure that would sit around it versus having their own system, having their own generation, and then a smaller kind of feed in. It's in a different space altogether. There's a much shorter kind of return on investment there. So I struggle to see some of the disadvantages that were once talked about. I think the disadvantage is really our own awareness and then wanting to get involved. It's complex. It requires more stakeholders to almost be part of it. It requires challenging discussions as well when you're talking about, commercial facilities, for instance, and we're talking about, discussions like load shedding. Load shedding basically means I'm going to start turning some stuff on and off depending on what I need at certain times of the day. I'm going to charge my cars depending on what your battery levels are when they get plugged in. It's not everyone's going to get the same. It's actually what we need at any one point in time to make the whole system work together and be harmonious. So that involves then, you're involving your HR, your finance people, involving people engagement teams. It's a different space and it becomes complicated. But it's a journey I think people, once they're in, they're willing to come on because ultimately it's for the right purpose.
Kayla, do you have anything to add there?
Yeah, I agree with that. We've engaged with many communities now over the years, and people are quite resistant to change, and they don't have complete faith in the technology. There's a lot of fear around new technology, and my wish is that more younger people get involved with making this change, because right now I don't feel that they're as engaged and as active in helping drive forward change, and it's going to be absolutely necessary to accomplish what needs to be done. And certainly when you consider that most communities have announced a climate emergency, have declared a climate emergency and want to take action, many of them have targets 2030, which is 8 years from now. Now, that means you have to fundamentally change things, and that is not going to change. People don't have that mindset right now. And when people talk about behavior change, I would say that's one of the most difficult things to accomplish. And so it needs to be a concerted effort that's made by people that are taking the time to implement the change that's required.
Darren, is there anything you wanted to add?
Brilliant. Actually, I think that's a really good point, Kayla. You mentioned, for me, it's the key thing. I know, Kaz, you touched on this earlier as well. I noticed we're kind of coming to the end of the session, Jordan. So it's a great way to kind of move towards the end is just to talk about people, and skills, and absolutely 100% what Kayla said. We are short of people. Absolutely, it is clear as day. I think I was at the CBI conference last week, and someone was there talking. The estimate is around, we're currently 120,000 people short in the energy industry, to deliver this transformation that we need. And we talk about energy, it's not just electricity. It's it's all the energy vectors together. Again, trying to bring transportation, heating. We're massively short of people, young people, we need to attract into this industry. We can at the moment offer such exciting careers to people. It's so diverse, whether it is, and again, all the things that Kayla touched on, is it kind of human resources, finances, contracting, kind of technology, implementation, architecture, computer sciences, ICT. There's a huge range of different career paths. Open to younger people now, and people changing careers, people entering back into the workplace after absences. But I think for me the most important thing in this discussion is it's not technology, it's people. How can we attract new people into our industry? We put such high barriers up for people entering our industry. Demanding we've been to university, or have a list of qualifications. The technical side of this role, I think, is pretty easy. It's the people side, it's the human side that's important. We can easily get people up to speed with the technology and the technical side. That is not a difficult thing to do. But it's getting people embedded in the industry, so they can then, deliver really long-term, fruitful careers. We can keep people in the industry. The opportunities that there are for people are absolutely just, manyfold in our industry. So, part of kind of my closing message, I guess, looking at the time is just one, is a shout out to people. They're the most important thing in all this to me.
I really like how you brought that full circle. We obviously started with people and we're ending with people.
Yeah, I'd love to tell you it was planned, Jordan, but it wasn't.
It was perfect. Is there any other points that anyone else wants to make to end the session? Kayla?
Just what a pleasure it was to meet everyone and to be able to have this opportunity to participate. Yeah. Thank you so much, Jordan.
Really good.
Thank you. And Cass, anything?
Yeah, just from myself. I echo a lot of the comments there around people. Definitely, skills in the technology centre has always been a kind of key focus. I think then skills in the energy sector is highly attractive, really highly attractive to a lot of the new generation coming in. And I think I've seen initiatives, and we're part of initiatives across the country, which is basically working with local councils to help to promote some of them jobs, some of them career paths in the local schools and colleges. So I think that is something that could be repeated, and more organizations like Schneider, like Hitachi, could definitely get involved to try and create the awareness that this is a positive industry to go into, and actually their knowledge and the diverse backgrounds that they bring are needed. I think from a microgrid point of view, just in terms of what's possible today, it really is achievable. I think it's about sitting down as early as possible with some of the right people and challenging how far can we go. Really not thinking of that kind of fear factor of what maybe has happened in the past or the last 30 years as kind of, this is the way it's been done, so people aren't ultimately going to change. I think if we can try and create it from the start, and that's the way we've done it with a lot of clients, is try and create that inception at the beginning. The rest of it is easier to follow along and bring people along on that journey.
Thank you. I really wish we had way more time to continue this discussion, but unfortunately, that is all we've got time for. Thank you to Darren, thank you, Kayla, and thank you, Cass. Thank you all for joining us. It's been a very interesting conversation.
Thank you. Thanks, Jordan.
Have a great rest of your day.